But yeah, in this section, we're going to be talking about equation solving. So we'll start with some basics. So for this lesson, we're just going to go through and solve what are essentially linear equations of exponentials. So we're going to be able to actually solve all of these with logarithms. And we don't really need to do too much to it. The strategy for each is always going to be to get started by isolating the exponential. And then applying a logarithm. And I'll always just recommend apply ln. And then that should get you almost somewhere where it's solved. So we've got this first one, 6e to the x equals 7. So we have to get this isolated first. So I'm going to try to isolate this thing. I will do that by dividing out the 6. So we get e to the x is 7 over 6. And then now we should be able to actually use the ln on both sides. So we'll get ln e to the x is ln of 7 over 6. Ln and e just cancel. So this actually does just give us our x. X is ln 7 over 6. And so that would be your algebraic answer. That is the accurate answer. If you round it to a decimal, you'll lose a little bit of information. So I do strongly recommend keep that algebraic answer in your solutions. Yeah, so B, I will go ahead again. Notice this one, I've got a base 2, but I'm still just going to apply the ln. So I'm going to start by isolating this thing here. And so what we're going to get is dividing both sides by 3. 2 to the x is 11 over 3. And then even though it's base 2, I'm still going to do a ln of both sides. So I'll still do ln 2 to the x equals ln of 11 over 3. And the reason why is because it's going to allow me to just take the x and pull it to the front. And that's going to get me in a place where I'm going to be able to actually solve for this x. So I have x ln 2 is ln of 11 over 3. So x will be ln 11 over 3 divided by ln 2. Just be careful where your divisions are taking place. So there's one division inside of the top logarithm and then another division between the two. But that would be this answer. Third one. Okay, so I want you to be really, really careful with this. If you try to just go straight ahead and start doing some lns like this, so if I just take a ln of both sides right off the bat, I'm going to run into some problems, mostly because there's absolutely no way to deal with addition. So taking ln of both sides is fine, but what people will tend to do after that is then kind of messing up a ln rule and splitting it up to be something like this. So this is not true. So this is not a rule of logarithm. Right, it does not follow from this first line. There's no way to split up the addition of a logarithm. And it also does not follow from the original, right? When we take a ln of both sides, it has to look like this. It has to be the ln of the entire left side, not piece by piece. The entire left side equals the ln of the entire right side. And so in this step here, we don't have that. So none of these work. I'm going to get rid of them. Just be careful of that. So same deal, we start by isolating the exponential. So we isolate that 5 to the x, and so I'm going to subtract the 2. So I'll get 7, and that'll be 5 to the x is 7 over 4. And so I'm going to bring it over here. So I'll do ln of both sides and bring the x down. And then divide the thing attached to x, divide by ln 5. So I'll get my solution, ln 7 over 4 over ln 5. And so that's going to be my answer. And just one more of these, and then I'll do a slightly harder one after. So yeah, always start these things the same way. I'm going to isolate for that 3 to the x. So I get 6 times 3 to the x is negative 5. 3 to the x is negative 5 over 6. If I try to do a ln, I'll get something like this. If at some point you try plugging anything to a calculator here, you should hopefully be realizing that this does not exist. You cannot take a ln of a negative. So -5/6 is not in the domain of the ln. Remember, it has to be positive numbers. So this x does not exist. Right, so not all equations are going to have answers. So we'll do one now where there's just a little bit more going on. So notice all of these ones have just a simple x in the exponents. We can make it a little bit harder, just add a few more steps by making that inside a bit more complicated. So we'll do one of those. All right, so notice that what we have now in the exponent of this equation is a bit more than x. We've got 2x plus 1 up here. It's not really going to change how we get this question started. So the same thing, we're going to start by isolating that exponential piece. That's 7 to the power of, right? 3 is not inside of that. So we're going to move stuff over. 22 minus 5 is 17. Divide by 3, it's just going to be a fraction. And then same thing, we're going to apply the ln to both sides. And as always, we're going to pull the exponent down on that logarithm. When you do that, you probably want to write a bracket on it, because that whole thing should be getting multiplied by the logarithm. So I'll put a bracket on it. Times ln 7 is ln 17/13. And now we just have a couple more steps, but we're going to now just solve for x. So before, all we had to do was divide by that logarithm to get x isolated, but there's a little more going on here. We could expand and simplify the left. It's not necessary. What I'm going to do is divide the ln 7 first. So I will divide that ln 7. And then I'm going to just write the rest over here. And then now it's just -1 divided by 2. So we'll subtract the 1. All right, so just make sure you don't lump that 1 into that fraction, and then divide by 2. So the whole thing needs to get divided by 2. So your answer should look like this. Right. So that's about as hard as it'll get for these simple exponential equations. In the next video, we'll look at some slightly more complicated exponential equations.